Mhm. Hello, everyone. Hello, boys and girls, ladies and gentlemen. Welcome to another episode of your weekly dose of Terraform. So, this time I want to focus on terragrunt because, well, that's one thing which I've been having some fun with for the last many years, and there are some things which I still couldn't figure out how to solve. So, please tell me if you can hear me well, because well, it's kind of traditional when I set up something, it just breaks about 20 minutes before. Hello, Artyom, and hello, many other people watching this from different part of the globe. It seems to be. Uh, well, let's get this started. Hello, distributed systems fanboy. So I want to say thanks to N0 for supporting my live stream, and I want to mention that during this week they have published several what is it, blog posts about some features which they've been working for some time. And by the way, hello Andrew. Andrew is a new hire to the team. So, well, what I can say about them. First of all, if you are into Microsoft technologies, you are more than welcome to say hi to them and ask questions during Microsoft Build, which will happen, I think, next month. You can go to n0.com/Anton and read about what is this product and how they're different from Terraform Cloud and what exactly Terraform automation and cooperation, communication. Anyway, TACO. So this is called TACO in short, TACO. Well, they have published some new things which they have been working on. You're more than welcome to go and check it out. So on this note, I want to focus on the issue which I have been proposing. So by the way, if you have any proposal for any upcoming events or any things which you think are relevant, not just for you but for other people, don't hesitate to reach out to me and we can maybe schedule it. I have already a pretty full schedule for the next, I think, 2, 3, maybe 4, 5 episodes. So there will be some companies coming and talking about how their product, which is definitely related to the most of listeners, what they do, how they do it, and so on. And I also want to show just some live coding things because I have issues with this, and as you know, we have limited amount of time during the week, and I decided to why not just make my own work, which I have to do for my customers, live. I mean, I'm not gonna to reveal any secrets or anything like that, but nevertheless, I want to kind of get things done. So without further ado, let's go into two things. So the thing for today will be, first of all, I want to show how to get a little bit better performance of AWS provider, and I will just explain what exactly I mean. It's not the best way to say that this is going to be a hack, but nevertheless, this is something what can save you some time and some some benefits you will definitely get from it. And then most of the time I want to focus on forage with terragrunt and explain what is it, what is the problem itself, what are the options. And I'm really looking forward to hear feedback from you guys in comments, in chat, or later in comments if you watch this later, because this is a way how the whole community works. I mean, if I know something, then I share it. If you guys know that I can do this differently, don't hesitate to correct me and say that, hey, this is bad, or this is wrong, or there is another way. I'm more than welcome to learn from you as well. So let's take a look into AWS provider hack. Okay. So what this is actually about? Well, I'm again a little bit skeptical to call it a hack, but it's a feature which you need to know. So normally what we do, we write provider AWS and then we write region, or we can use environment variables for that one. But this is a thing which I want to emphasize. Previously, like historically, I don't know, Terraform 0.11, 0.12, or even before that, this had significant impact, like significant, approximately 10-20% was easily cut off if you just enable this skip for a bunch of these things through. I guarantee that you would have about 10 to 20% amount of API calls to AWS provider reduced if you enable these skipping options. Now this is not the most important part, but still it is relevant. So you can specify these skip arguments. What these skip arguments tell? Well, Terraform AWS provider, when talking on your behalf to AWS endpoints, will not perform certain actions because you decided to have this verification, let's say later. For example, credential validation. There is no need to validate credentials in advance because, well, something will simply fail. As well as region validation. Well, if I specified non-existing region or a region which I don't have access, like AWS top secret 1, which unfortunately I don't have access to, then this skip region validation is not necessary to do. And again, it's one API call, maybe two API calls, but in many cases you don't need to have unnecessary calls to happen on your behalf. So you can most likely, like literally very safely, to enable 4 of this, and you will see some benefits. The last one, and again, all of this is documented in documentation. I'm not going to share a link to documentation. You can go to registry and you can read about them. The last one is a little bit tricky because when you work with resources like API Gateway or when you compose in different IRNs, if you have this as true, you will have surprise. So be careful about that one. And again, it's documented. So the second thing here is that you can specify the same parameters inside of backend communication. So when you keep your S3 state file, Terraform state file on S3, you can also tell Terraform to do similar skip. 2 of these checks make sense, the rest doesn't make sense. So you can enable this and you will again reduce amount of API calls. Now let me show what exactly API call means. Okay, so if I run Terraform init, I will download this module. This is just for fun, just to say that I'm actually trying to create some resources. So there will be some intention to call an API. And then if I call Terraform plan, if I put time here, time Terraform plan, I can put it like this, you will see like 3.5 seconds. If I run it again, of course it will be similar, well, 3.8. Well, now I'm actually streaming, so it's much slower than when I normally do this. So it was like 2.8 seconds. But now I'm streaming, which means I'm uploading approximately 1.2 megabytes per second. Okay, that's a lot. Okay, so you see the point is like 3.8. So now if I remove this one, it should be even more than that, because now I'm issuing a little bit more API calls, and it will be 4.2 seconds. And again, what I'm doing here is just calling a couple APIs, not more than that. I mean, there are just 2 resources which has to be created. They don't exist, so there is no need to do a refresh or anything like that. So 4.2 seconds comparing to 3 point something. And you can see that now it's quite big difference, 3.67 versus 4.2. So half a second just to enable these 5 skip checks. But well, how can I prove that this is just time. Well, if this is not convincing, let me show you another way how I sometimes can confirm that something is working as expected. It's just by evaluating the size of log. So if I now run, I have tf log trace, and then I output it into notskip.log, and if I run plan, then this notskip.log file will be created. If I now uncomment these things and I store this into a file which is called skip.log, so similar things, but now let me run this one, and you will see that when I run with skip enabled, there are a little bit less activity, a little bit less in logs, a little bit less API calls being made. Again, 800 kilobytes, I'm not gonna to diff because it's just impossible, but still, this is on one resource. When I have 500 of resources, I can easily see difference in half a minute approximately with enabled and with disabled. So keep this in mind, and in most cases this 4 is absolutely no-brainer. The last one is a little bit tricky sometimes. So this was 13 into the stream, and hopefully you already learned something. If you learn something, you know what to do with YouTube, right? You have to click somewhere, the fingers up or down. So just remember that I have no clue how YouTube respect this. Anyway, let's move on. I'm not doing this for likes, comparing to my son who's streaming on Twitch for likes. Okay, so let's move on to another thing. Again, if you have questions, please write in comments, and I can explain maybe something differently. So the biggest thing for today, and that's what I have not been kind of playing at all, because again, as I said, I want to solve a task which I need for one of my customers while learning this for the first time myself. If I find the solution during the next half hour, it will be great. If not, then I will find it after the stream and somehow make it for the customer. So let's see what is this overall. Okay, so what we have to look into this folder called forage, terragrunt, and then there are 2 files. One file is inside of bucket folder, and another file is in the root directory. If we look into the content of the bucket folder, I guess that people who are watching this are already pretty familiar with the way how terragrunt works. If not, I have been making, I think, 2 or maybe even more episodes about just terragrunt and how it works, and yeah, there are a few things which you need to know. You can read documentation, and anyway, there are enough places to learn about how terragrunt works. So what I want to do here, inside of bucket folder there is a file called terragrunt, where I'm calling one S3 bucket module, and I want to create a bucket, so that's why I provide some arguments like bucket name, as well as some other argument, force destroy. So that's okay, I can make one bucket like this, right? If I look into the parent folder, there is another terragrunt.hcl. Again, it can be structured differently, but just for everyone to understand what's going on, I will explain it like this. The parent terragrunt.hcl file is being included by this statement. So this statement include path, and then find in parent folders means go upwards from this location and find first terragrunt.hcl file and include it. So in essence, if I take the content of the outwards terragrunt.hcl file and put it inside of this one instead of include block, like literally instead of here, it will be exactly the same. Well, maybe I need to combine this Terraform statement somehow. But anyway, you get the point that include is just like include in all other programming languages. So this terragrunt.hcl file has some configuration. Most interesting one for us is just configuration for remote state backend. it's not necessary to have here, I mean, we can use just normal local Terraform TF state file for this case, but for me it's just easier to use the same things pretty much everywhere. So I have this remote state configuration to keep this file on S3 under this key, and also I'm generating Terraform. What is it? I'm generating provider AWS block with pretty similar things which I just explained earlier. So what I'm going to have is I have to go to bucket folder, and then if I run terragrunt init here, what is going to happen? So terragrunt takes the module, put it inside of terragrunt cache folder somewhere here, and this is the content of the module itself, plus there are a couple of files being added. Main providers, which as you can see is generated using generate block, and there is backend file which is generated by remote state block in terragrunt.hcl file. So this is pretty standard things, nothing really special here, and that's again very well described in many places. I'm not going to go through that one more time. So now let me describe what is actually the problem here. Well, I want to, or not problem, what is actually the situation. When we are working with terragrunt, we are calling modules, and that's the best part in terragrunt, is that you eliminate the whole need of describing variables and outputs, because you can see that there is no configuration of or declaration like variable block, what is bucket type string, some description, some default value. All of this is taken care of for us because we are actually have terragrunt cache folder where things are combined for us, which is great. The same for outputs. We don't have outputs blocks, but everything is available. So now what I can do here is if I run init and if I run apply, I'm pretty lazy. I almost never run terragrunt plan, but that's just the way how it is. Yeah, you noted one more thing. That's actually what I forgot to mention during last improvement of for the provider. Usually when I work alone or when I know that there is no one else working, I don't need to have a state log at all. And why this is important is that you will be surprised how many calls are being made to DynamoDB table for locking, unlocking, updating records in Terraform state file. It's not the problem of performance. It's usually a problem with the latency. Like now I am streaming and all of these logs are happening, I don't know, it's like easily 1 or 2 seconds just to talk to all of DynamoDB records and update them as I do. So in general, if you work alone, you can write terragrunt apply, I think something like this, log equal false. Maybe it works, maybe not. So, well, at least now it doesn't tell that it was occurring log. So this was faster. Maybe you didn't notice this. Well, I didn't notice this myself, but I know that it performed fewer API calls to DynamoDB. And again, it's all important when you know that you're working alone or you're not working with like critical environments or you want to iterate much faster. All of these small optimizations play a significant role. Well, maybe not so significant if you apply this in production or if you put it into CI/CD pipelines and so on, but for the development, that's important. Okay, so what I want to do, I want to type yes, and I want to create this bucket, right? This is pretty standard things, nothing really really crazy happened here. The bucket was requested with this my random bucket foo. When I was trying to write just this one random bucket, it was already taken. Then I started to add foo, and then this amount of O is enough to be unique. Okay, so that's one thing. I'm pretty happy with it. What can I do now? Well, I need to have another bucket, and that's exactly where the challenge starts. So how can you use terragrunt to create two buckets? Well, the easiest approach, of course, that's what I've been doing many times and many actually years, is I simply copied this stuff. Okay, I have bucket and I have folder called bucket2, and that's it. So now I have configuration for another bucket, which is well, my another random bucket, just to distinguish that they are different. So there is bucket and bucket2. Great, I can go to bucket2, I can run terragrunt apply. Well, I probably need to run terragrunt init as well, because there is old configuration inside of terragrunt cache, but I see that it was smart enough to figure out that well, that this bucket was not created. Cool. So if I run yes, and now I have two buckets. I'm extremely happy. Now I have a request to create 25,000 buckets. How can I do this? And this is where the problem starts. Okay, so let me just remove this bucket because it's not really relevant. We can make fun just in one bucket. Terragrunt destroy. So you can see that I can make buckets by copying files, right? Who is impressed? If you are impressed, put thumbs up, and well, and probably you should not watch what we're going to do further, because now we will do some hacks. Okay, good. So this is done. Now let's go to this one. We can drop bucket2, because that's not the good way, right? We cannot copy paste things. Well, we can, but we need to do this in some standard way. We have to introduce some tools for that. Yeah, hello Michael, or sorry if I read your name incorrectly, but hello anyway. So what I want to do, I want to call many buckets. How, like in ideal way, how I can do this? Well, the first way which comes to my mind is that, okay, I want to make another module where I will pass values like this is just example. So I want to make a module where I will pass buckets, and then bucket1, and then I'm gonna to pass some maps. Okay, so bucket1 with some random name and some arguments to it, and then bucket2, and so on. So bucket2, and this is another unique name. So something like this. I like this way very much, because then I can use different features like locals somewhere here, and I can somehow put this into, let's say, one global map where will be like common settings for all buckets, and then I will merge or override, let's say, just bucket name and take the rest from the locals somehow. So I can do this pretty much like quite nicely. So let me implement this solution first. I think I know some drawbacks in this solution, but anyway, I want to have this created. So I will make another directory, and I will call it modules, and then inside of this modules I will make another directory which I will call S3 buckets. Okay, S3 buckets. So this is intentionally plural because I want to make a lot of buckets, right? So main TF. What I can do there is pretty much pretty much the same thing here. So bucket from the registry, I think version is 2.0, and it should be for each inside of var buckets, and it should be variable buckets type. Well, type is actually a map of any, but I really dislike writing this one, so I usually write any, because there are a lot of benefits in writing any and then resolve these dependencies or this process inside of place where you actually use it, somewhere here, using different to-map structures or try. Okay, so variable bucket, and then inside of the bucket, what I will have to do, it will be each value dot bucket. Well, this is required, so that's why it is force destroy. Tags, well, tags I don't care about them, so let's leave it like this for simplicity. Of course, you already understand that S3 bucket itself expects a lot more, right? So if you look into the source code of like what kind of variables it expects, it has how many variable? It has 26 variables available. So to do that, we need to kind of write this block for other variables, and it will be pretty big, and it will be already ugly. Okay, so what we have here, let me summarize this one a little bit. Okay, so this was good for one module. Now let me use this one for several, so I need to figure out 1, 2, 3. I have no clue how many else to put, so let's leave 3. And I mean, I know how to count this, but I just don't want to guess it immediately. I want to make it fail first. So modules S3 bucket, and this one we don't need. Okay, so we are going to use this one, and we're going to pass one buckets, and we want to create 2 buckets. That's pretty much cool. Let's just for well, it's not random enough. It should be 1 and 2, just so that we can understand which bucket is which. Okay, so that was pretty straightforward. Now, if we go and run terragrunt init once, we will see that, oh my god, this was wrong way, because we went a little bit too high, so we probably need to do 1 level. So what is cool in this approach is that when I type too many ... I can see exactly what kind of path did it try to read from, and I can see that it was like very high level. So that's why I just need 1. In some of my projects I have 9 ... and this is nightmare. This is like 9 or 10 or sometimes 8, and you have to run it, and then you have to see how things work. Okay, so terragrunt was downloaded. Now we can see 2 folders. Well, do we need 2? Well, let's keep them. Anyway, the source of truth right now is inside of this small folder, where we can see that there is main file, as we expected. We have some provider backend there, so which is good. So now let me run terragrunt apply. Again, it can be with log false, log true. That's not the purpose of this thing right now. So what I have here, that's like the first one is, of course, since I have changed name, it tries to recreate it. That's okay, that's we can live with. Then what we have here is that we have 2 invocation of modules. So we have module bucket 1 and bucket 2, which is fine, and we can live with this. So we have actually created 2 buckets, or we're planning to create 2 buckets. That's exactly what we wanted, right? If we run yes, well, probably will work. So 1 bucket will be removed and 2 buckets with new names will be created. For fun, we can actually output as well. And we can output, and value will be module bucket, and well, it should be map, right? So it should be for kv in module bucket k, what is it? Okay, no, who cares about this really? No, probably. Anyway, I was just wanted to write something smart here, but then I figured out that I don't know what to write here. So let's pretend that I know what to write here, but I'm lazy. Okay, so one more time. If I run this code, what I have here is the following. We have 2 buckets being created because we specified that we want to. So pretty straightforward. Let's talk about drawbacks of this approach. Well, the first drawback in this approach is probably the biggest one, is that I need to write this code which is very repetitive. So for 26 other parameters which this module expects, I need to write the same things. I need to write, ACL equal each value.acl. Actually, ACL is optional, so we need to wrap it in lookup in each value by key. And what is default? Well, let's say null, because sometimes we don't want to provide ACL, but we want the default, which is inside of the module itself. So we have to write this one. Actually, we have to write this one for all other parameters as well. Can we do this better? Why not? I'm kind of already derailing from my plan, because I think I start to like what I'm doing. So if I now put this here for all other properties, again, it has to be for all 26 of them. Okay. So what if I put this stuff here and I'm creating this bucket, and then I kind of agree that the variable will be the following. Maybe that's like a pattern itself. It's like when you want to call multiple modules from single terragrunt layer, you can use, we can call it a special type of feature provided by Terraform AWS module, which sometimes is called stacks. We can call stack and then let's say multiple, something like this. Then, oh yeah, I think it's cool. Okay, yeah, I will I will implement it in a bit. Let me just put it here. It's already not so bad as I expected at the beginning, but let's focus on this one for now. Okay, so this module is having issues with repetitive things, right? So you as user who wants to make many buckets need to do things which we inside of Terraform AWS modules don't want you to do. Like, don't do things which other people did for you many times. So that's a good part. So what you can do here is like you can copy paste these things. This is one way. But what if we inside of the module itself make another approach for you? Let's say this is one way how you can do this, and Mm. And what if we put this inside of the module like this? So you are not using your own things, because honestly here it's very hard to do something creative. And again, the purpose is just to make a lot of similar resources. So what if you just use one module, but we make another sub-module, and we can call it stack, and then we call it multiple. Okay, so inside of multiple, what we will ask you to do, this stack multiple, again, I have this module locally, so I can easily reach out to this locally. It's users, so this one, then stack multiple. Okay, so if we look into the source code of the module, this is again just local copy of this module because I have them all here. So somewhere here I can make the same thing and call it stack and call it multiple. Well, that's wrong name. Multiple, like this. So what is gonna to be inside of that module is, if we look into, let's say this guy, and if we look into this stack multiple, and we call it main TF, of course, just because why not. So what is going to be inside of this source, or I actually copied from wrong place. It's better to take this one. So I'm going to take exactly the same source code, but since it's not part of what is differentiating customer A from customer B, it should be, should it be, well, yeah, it's something like this. So for each, and then all of this bucket, force, ACL, and the rest 24 other parameters which are kind of available inside of this module will be generated. I mean, it's quite easy for us to generate because we know where all variables are defined. So they will be here. Maybe buckets is not good name because it should be very unique. I mean, very identical pattern pretty much everywhere. Bucket, and well, it should be some output. Let's figure out what to write into output. So this output will have to be, let's take something from, well, that's not good one. Let's find something more complicated. I think event bridge is pretty complicated enough. Well. Here we do some sorting, just IRNs. No, that's too boring as well. Okay, let's call it outputs. Really creative, right? Output, outputs, input, input. Maybe inputs, because we expect a lot of items and a lot of outputs. Module dot this, I know that this is not the best way, but again, I want to make this as a pattern which is really common, because I don't really understand the difference between S3 bucket and IAM user. Well, they're just a resource which can be created. Okay, so module this, is this right? Output module this, or should be the key. Okay, maybe like this. Okay, anyway, so what I want to have, one more time, I have stack called multiple inside of S3 bucket, and I don't need this guy anymore because, well, that's not it's not so special. here. No, sorry, this one. S3 bucket, is this the right place? Ah, right, okay, yeah. So this one is correct, though I'm not sure about line 17, but we will see it now. So let's try to run this one. This one is not needed because that's too boring. So when you say that, hey, I want a lot of things, you call it this location and you specify buckets. It's not buckets, it's inputs. Well, inputs, okay, maybe. So now let's run again. Stack multiple stack Terraform AWS S3 bucket multiple. Well, did I copy something wrong? Oh, right, okay, yeah, it was wrong source. So run it one more time. Good. So now if I run apply, what I'm gonna to have, well, what I expect, yeah, 4 to create, 4 to remove, and bunch of my buckets are here. Well, this is a little bit list of maps is not what I expected. I was just expecting map, but anyway, this is a minor issue. What I'm glad to see is that in this approach, I don't have to repeat any of my outputs because they came straight from the module. Though I still need to do some work inside of module itself. But again, I'm not concerned about what I have to do as a module developer because I do it once and then I use it pretty much everywhere. As soon as I identify this pattern, I can make it happen pretty much everywhere. So this is one way how this can be solved. And again, I like this way pretty much. How I can... let me see. Yeah. Okay, so if I make stack and I call the same module, maybe I don't have to call it like this, of course, because it's just a relative path. So there is no need for me to go to the registry because I'm already pointing to the same module here. Why do we nested inputs here? Why do we input nested? Well, inside of bucket, let me answer the first question. So why do we need nested inputs here? Because I want to create many buckets from a single folder. So I have one folder called bucket with one terragrunt.hcl, and I want to create dynamic list of or dynamic map of my items which I want to create. So pretty much. So bucket 1, bucket 2, if I want, I can make changes here and they're not going to be destroyed in any way. Only one item will be removed. So that's why I use nested. These inputs, if you are asking about that one, maybe this inputs is by terragrunt, and this one is the name of the variable declared inside of this stack multiple. So it is here. Maybe a name is not the best one, and I know you guys don't like this in outputs. I understand, and I've been pretty much answering why this was necessary for so long time. Like people were asking me why this is everywhere. It doesn't make a lot of sense, and I was explaining this, and then one day I just decided, okay, let's get rid of them because my explanation is not relevant anymore. It was relevant back in Terraform 0.10, 0.11, beginning of 0.12, but not anymore. Value to, okay, let's see. For the outputs, I think you can avoid the for loop by using splat as module buckets value to be outputted. Well, that's the whole point. I don't care what people who use this module want to get back. It's up to them what they want. So if they want, they will get one item. Maybe they will get many items, I mean many outputs, many properties of resource. But anyway, it should be, I don't know if to-map will not work here, but yeah, I should convert it into map anyway. Okay, let's see what else. What else? Alexander, hi Anton. Oh yeah, I can put this into screen. Exactly. That's pretty cool. Very interesting. Maybe question for future streams. Can you show some examples of import resources into TF state from AWS account which was created manually by ClickOps? Well, this is pretty well described in documentation, I think. You can well, there are some things which are not described and some things are very complicated, but in general, if you go to documentation and read about how import works, you will get 99% of cases kind of supported and everything will be fine. The hardest part there is going to be related to import of related resources and how you will have to write code so that you can actually import. Well, there are even more challenges. Sometimes module default value is not respected when you import it and it fails. We had this issue with Lambda module where function name was required no matter what. And when you import it, you don't know yet function name. Anyway, there are a few challenges. So if you want to know more, please ask more specific things and I will be trying to help you with that. Okay, any other things? And then just use this terragrunt Terraform code with this TF state file with imported objects. For example, import VPC and network, and after create EC2 instance by terragrunt. Well, this can be separated into running, into understanding how Terraform import works, and once this is done, then you run kind of Terraform or terragrunt to create the remaining resources. So it's not really so far from the things which described in documentation. So I'm quite sure you will find a lot of this in documentation, and it's very well written. There is not much value for me to cover what is already described there. But anyway, thanks for asking or proposing. Okay, right. Well, I have other things which I was actually planning to do, but I like this approach actually much more. So I will not probably implement the next approach. Instead, what I'm going to do is that I will make changes into, for example, I will probably start with S3 bucket because that's one which I need myself. I will make the generalization for this code a little bit better. The way how I can do this is I can show you guys now. It's quite cool. Particularly I'm interested in generation of this piece of code from variables. How can I do this? In two commands. First, I need to grab information about what kind of variables are present, right? I need to get all of these names. Then I need to generate what I need to do. Then I need to put it inside of module this block somewhere here. I think it's awesome, and well, if I don't think that this is awesome, who else may think this is awesome? Let me just run it. Bucket's already owned by you. Well, I know that's That's why I wanted to do this. So I did some change, and then it complains that bucket is already owned by me. I know. Okay, it doesn't like terragrunt init. So it doesn't like this relative path. Maybe I need to do something about it, but right now I don't really care about this source because it's gonna to work. That's ACL unsupported argument. What? Okay, let's put it back, and I will fix this later. It's minor thing. It's pretty boring. Well, instead, I want to do some fun things with HCL code generation because it's needed here. What editor is that? Well, it is so slow that I don't want to recommend it to anyone. Right now, it's eating approximately 80% of CPU, and my computer is warm. I live in Norway. I know that it's good to have something warm, but still IntelliJ. Okay. So okay, let's do this. So I run space. What is space? Should I go to space? What is space? Space is this one, right? Space, integrated team environment. Well, I didn't click there, and I'm afraid to click there because my computer may hang up. Sometimes IntelliJ decided to restart, or there is some panic somewhere. So you can see that here it says error, like on the bottom right, that there are some errors, some crash happening periodically in some of the plugins. But I don't use a lot of plugins as well, so I'm not really a big fan of IntelliJ for the last few years actually, but there is nothing else. Well, actually there is something else. For most of my work, which is not streaming, I use Visual Studio Code, but it's a little bit too early to say. Okay, so one more time, I want to say yes, and I want to create these two buckets, and it will be created. Okay, cool. So I have a lot of things back, and I'm quite happy with it. Yeah, so VS Code is one of things which I use myself, but it's topic for another episode, or not one, but actually many more. So let me focus on this one. Well, we have 5 minutes left. So what I want to just start is the following. I'm gonna to do cd s3 bucket stack multiple. Okay, so I'm inside of this folder. I can see this file. So let me see. So the thing which I want to do is to automatically update these things. Okay. Do you have this on GitHub? No, there is nothing smart on GitHub. I mean, from today episode. No, so only S3 bucket module is on GitHub, but since I'm making changes, they're very rough, and I have not planned to publish this on GitHub yet, because there is not much sense in this yet. So HCL edit is the name of the tool. HCL edit is something what I'm gonna to use. Get variable no variables tf get what else I can do. So get, and then I can put variable dot ACL, right? No. Well, it's a little bit tricky, but still, if you know what you want to do, well, you can probably search in history, but HCL edit has probably block. So, okay, it's probably block get variable.acl. Right, okay, good. So if I now put variable, right, I have a lot of variables. So what I want to do instead is somehow identify these names of variables. How can I do this using different tools? Well, in which project I do this? In security group and in some other projects I use what I do, I convert these values into string, just because I don't care about them at that stage, and I convert it into JSON, and then I use JQ. There is also HCLQ, but I don't use it so often myself. So HCL edit block get variable is one of the commands which I can use to get these blocks. What I can also do is it's not block, but it's attribute, right? ACL, no, ACL type. Right, okay. So I can get attributes. I can get what else I can get? I can get block attributes, and maybe I can get what is body? Body. Right. Okay. Body is body. That's not what I want, but yeah, body is not exactly what I wanted. So I probably need to get variable. Well, how else I can get it? I can use what else? Well, I can use grep to get these names, because they always match in certain expression, right? Grep. Well, yeah, okay, maybe grep is not so bad. Let's see, variable. But how can we put it back into Terraform? That's the whole point, that as a user, I mean, what I'm showing right now, I will have to do as module developer. So this thing will be automatically updated. I mean, this guy will be automatically updated based on variables present inside of this module. And you as a user will just have to put it into, say, like, hey, I need to call this stack and pass a bunch of different resources here. So you will specify inputs equal, and then any key which you want, and then same things which you had before. So same inputs which you normally had in Terraform, in terragrunt, sorry. You can call the same stack from other places, not necessarily terragrunt, but just okay. I think I don't want to spend time on this right now, to be honest, because it's gonna to take some time. But the point is that I like this approach more than the one which I was planning to do, but I still want to mention it. Maybe it will be useful for someone else in the future. This one I will work on later and maybe implement it as part of public module, because I don't want everyone to come up with a unique solution just for their company or for their use case. I see a lot of people think that, well, Terraform AWS modules exist, but if we use them, then we don't have anything else to do. So no, we will fork it, we will optimize it, we will do our crazy things there instead of just using them. It's hilarious sometimes how people want to get work for themselves. I mean, I never wanted to have work for myself if someone else can do it better or faster, but it's just me. So what is the next approach, or like the last approach which I had in mind for this one? Just one second, what is it? That means this can enable a basic application developer to just specify the core requirements, and as module developers we can use variables from other modules to get auto-populated into new modules. Well, that's the whole point of terragrunt and pretty much Terraform as well, where you have separation between module developers and application developers. So yeah, check out what is actually a terragrunt like in general, and I'm sure that you will understand it much better than me explaining it right now. So let me explain the last approach which I was thinking to do. So this approach is good. I will somehow let me make another bucket 2. Okay, I'll just you see my computer is just slow. So what I want to do, get rid of this bucket 2, this source, include input. Yeah, okay. So pretend that inside of bucket 2 I want to have the same input, because this input is very kind of dry, and we can make it even more dry by using different features of locals or default values and so on. Pretend that I want to use another approach, which is the following. I want to reuse these inputs, but I'm using the module where this stack pattern, which I described earlier, is not implemented. So what can I do? Well, I need to use code generation for that. For example, I can put this generate block somewhere here. So this file will be a multiple TF. Usually, if file is automatically generated, I like to prefix it with underscore. That's just me. I say that I like it, but I see that in some projects I don't do it, but I still like it. I still like myself when I do it, because it means that this file will not override the file if it comes from the module itself. And some people don't follow convention inside of resource modules. They put files with very different names by service or by something else. So let's say multiple is going to do something. So what we can put here, let's think about. First of all, we need to call a module which is going to be modules empty. What is this empty module doing? Empty. Let's put some file in it. Git keep, for example. So why I do this is because I want to use functionality of terragrunt, like remote state, for example. But inside of empty module, there is no real Terraform code located. So instead, yeah. Oh, that's a really good question. Well, I'm trying to revise my Greek knowledge, and I could not read your name, but I'm impressed with so many characters which I have no clue how to read. Anyway, probably a silly question, but what happens if the maintainer of a module decides to delete it? So when I read it 10 seconds before, I I read it, what if the maintainer of the module decided to die? But okay, the delete is not so bad. So, well, if module maintainer decide to die, Manolis. Okay, so Manolis, if module maintainer decide to delete it, that's I have no clue what's going to happen. I actually had a lot of expectations myself about Terraform registry for the last 2-3 years that they will actually improve it and do a lot of cool things, including caching of the modules. But I'm not sure if this is implemented. So what I mean is that if module maintainer decide to delete the module itself from GitHub, there should be a cache inside of Terraform registry somewhere. But from what I have seen, all requests are coming directly to GitHub. So there is no cache as far as I understand. But also if module maintainer decide to delete the module from a registry, well, obviously cache cannot be used because module maintainer decide to delete it. So please ask this question somewhere, I mean, officials of HashiCorp. I'm not working for HashiCorp and I don't know what are the plans for the registry. I mean, there are a lot of interesting things which are related to the modules itself. But what I can say is that I do my best to not delete them, to not introduce bugs, to do best intentions pretty much every way. But of course, sometimes things are not going as planned, and well, if I don't delete it, I can die, and you still want to get some something. So we are a little bit off track, but let's say, okay, so we call this empty module and we use generate block to generate module bucket, and what we have there is pretty much the same content, right? Let me think about this. So we use for each inside of buckets. These buckets, well, we can call it inputs because that's what we have here. And that's it, right? So this is what have to be implemented. So if I now go to cd tf those for each bucket 2, and if I run terragrunt init modules empty tf those, oh, that's too much. Did not find any Terraform. Ah, right, of course, it has to be inside of here. It has to be any Terraform file, TF file. Good. Otherwise, it cannot recognize that this is a module. So, what we have, if we look into the bucket 2 folder into terragrunt cache, we have multiple thing here, and we use for each inside of module. So essentially, that's exactly what we just did with stack, but we put this kind of code into the module itself. Is it good? Well, now you have to maintain all of 26 properties yourself. I'm not sure if you will be so happy to do this, because this code is just boilerplate. It would be much nicer to write, instead of all this, to write just inputs equal var inputs, something like this, right? And that's it. Everything will be handled inside of the module, but you can do it like this as well. So what else do we have here? Now if we run this code, we should be able to have a couple things created. It takes some time, I don't know why, but yeah, it tries to create these resources. It will fail because these buckets we already created in folder bucket, but well, that's the same approach as I have in stack, but I don't think this is nice enough, because you will have to maintain it yourself and you have to think about this. So it's another way of doing things. Alternatively, what you can also do, and that's one of things which I'm not sure if I like it, but still, what you can do is that you can write for template. What is it? Template, not in interpolation, but template. Anyway, you can use loops inside of strings, right? Template loops, or how it's called, somewhere here. So for let's say you want to make many buckets, then you can call it something like in var buckets, and then you can use this k inside of this, so you will have a lot of similar modules block, which is cool, but you have for each now. I'm not sure why you would need this one. You may need to use this kind of approach if you have a lot of code which you have created before, and now you just don't want to change it, because you will have to do some renaming, because you will have to handle this inside of maps somehow. So it's like conversion from linear structure into a map. I'm not sure. But anyway, this is approach which I was thinking. I'm not sure that I like it. Instead, I will implement the one which was part of the module, which can be used for for terragrunt or anything else. Let me summarize, and let me just look into other modules which I have, where else it can be useful. So let me just look into, like, where we create not one thing, but usually a lot of things. So ACM certificates is unlikely because they are rather customized. Sometimes, they require a bunch of different properties into it. Oh yeah, and one more challenge which has to be taken into account is how to pass provider block into the module which is used. So for example, if I use bucket and I'm calling this stack and this stack, this is one thing which terragrunt will never have probably implemented, is inside of these inputs, there is no way for me to specify that create this bucket using provider, let's say AWS US East 1, something like this, because you have to use it like this according to Terraform, but terragrunt doesn't understand that this is feature of Terraform, and it will fail because it expects only plain types. So yeah, you cannot specify providers inside of inputs to the Terraform module from terragrunt.hcl, which is sometimes problem, but in most cases you just have to split it and you have to handle provider different outside, like in the high level. Okay, so what else? ACM, maybe yes, maybe no. ALB, no, you always create one or two, but it's okay to have multiple folders calling the same stack. API gateway is pretty good example of where this doesn't make a lot of sense, because in API gateway, for example, there are already maps of integrations, for example, where integrations can be already a map of many different things, this is a route and then a bunch of parameters which we pass into it. So that's okay. I mean, it doesn't make sense to create many API gateways like this. So skip this one. AppSync the same. Atlantis, of course, not. Autoscaling, does it make sense to create a lot of them? Sometimes yes. Well, that's a really challenging one, because here we have, like inside of autoscaling group, thanks Brian, who added all of this quite recently, we have support for all features of launch configuration, launch template, autoscaling groups, like all kind of rolling updates and all kind of features available there. And it is quite powerful, and I think it makes sense to have support for all of these variables to be provided as a map as well, because we can create a lot of autoscaling groups if we want. Though I'm not quite sure how it will work in reality, because usually you create like 1, 2, 3 autoscaling groups. It makes sense actually to create a lot of them if you create, let's say, autoscaling group and you have to configure it to be located in specific, let's say, availability zone, because you have EBS volume there and your EBS volume is dependent on availability zone. So it makes sense to think about autoscaling group. CloudFront, well, yes and no. It's unlikely that you have a lot of CloudFront distributions anyway. EC2 instance, yes. That's a good example. Oh my god, EC2 instance is one of these examples where I remember I added instance count. Why I added it a long time ago is because somebody said, hey, I want to launch many instances. Like, okay, if you want to add many instances, here is instance count. And then it was one of the first module where we have this operator, because we always, by default, we create a list of resources. So you can say you want to create a lot of instances with a bunch of different configurations. So yeah, it's kind of already implemented there. So there is no need to have stack for that one, because it's already supported. You can specify list of resources. Okay, ECS, EKS, no, LB, no. Yeah, IAM users is definitely high on the list, because you definitely want to have possibility to create a lot of IAM users with a bunch of different login profiles, maybe access keys and so on. So yeah, that's definitely high in the list, and I will take a look on that one. As well as Keeper, Lambda. Well, Lambda would be pretty cool to have. Yeah, to create a lot of resources from the map, but it's not so much requested. So the rest, RDS, well, no, not really. Route 53, especially records. Oh yes. For records, it's must have, absolutely. Yeah, so records is definitely very important thing. Cool. So, and the 3 bucket, security group. Well, security group in general has to be rewritten. SNS, SQS, yes, for sure, because we usually create pretty much SQS for everything, like dead letter queue for all lambda function. It can be different, but it can be also repeated. So yeah, VPC, no, but there is a case for specific resources like subnet, but it's another story. Okay. Yeah, okay, so good. So I have pretty good understanding of amount of work which has to be done. So I think that's pretty much it for today. Let me go back to this one. Yeah, just as a conclusion, talking about this for each iteration, this for each looping variables will not implement was created a long time ago before it became available inside of Terraform. So 13.0 is when for each was introduced, but this decision was made before that. And I don't think there is anything what terragrunt has to do, to be honest, because, well, as I can see, it can be implemented on the module level quite easily and quite elegantly. So there is no problem with that one. But yeah, I'm completely for that solution. No options, do nothing. That's really good. Yeah, we must wait for this. That's exactly. Okay, good. Count that generates. Oh, you see, they have. It's it's a good idea to consider that too. But okay, yeah, right. So implementation details and yeah. Anyway, that's not what I want to finish with, and I just want to say thanks a lot to N0 for supporting my live stream, and hopefully everyone is doing great, and well, that's pretty much it. Remember to subscribe to weekly.tf because that's where I'm gonna to continue publish news. Earlier this week I published kind of my last bits of news related to Kubernetes. I personally tired of Kubernetes so much because it just in most cases it's abused or misused, or people think that this is great but they use it incorrectly. So if you agree with this one, that Kubernetes is unnecessary in many places, then I kind of virtually hug you. Okay, that's it for today. Thanks everyone for attending. Thanks 15 people who are still watching this. See you. Bye.